Cool, let's go. All right, so I think we're going to get started now. So there are some papers going around. Those are just different tips from some of the different departments. You can take both, one, or neither if you'd like. Totally up to you. But thank you all for coming. I really appreciate it. So we're going to have this designated by section. So if you don't want to stay for the whole thing, you don't have to. I do encourage it because even if it's not your division, it might still have some really helpful tips. So first up, I will pass it off to Dr. Way.
Thank you, Sam. Nice to be back up here. I guess I'll preface my presentation just to say that I do have some general advice to offer, but I will go into specifics about the kind of OPs we often see with students who are related to organic division. Okay, so thank you for showing my group. Actually, I changed my group webpage now. We went canoeing earlier this month, but that will change again later this semester. Okay, so when it comes to organic chemistry-centric OPs, we can broadly categorize them into three different areas. So there's a group of people who focus entirely on synthesis or bond formation, so that includes catalysis. So I have some specific information about that. There are people who are involved in the chemical biology interface, and so that takes on a different set of challenges to address. And the last one, of course, is materials, our growing materials area, and what sort of thoughts should be going through your minds if you're planning to do one of these. Okay, for all of these, though, and for any OP in general, one thing to really be sure to do is that, first of all, anything that you consider to be a novel proof of concept, make sure you have a good argument for that. Don't assume that we believe it's novel, so please do support that, one. Okay. The second is even the best ideas have some weakness. Do your best to identify the potential pitfalls. Don't try to hide them, just recognize that they exist. And once you've identified those, what you want to, the best way to approach it is to come up with alternatives, right? A plan B in case the most critical aspect of that problem cannot be overcome. Okay, and it's not that you have to go into your OP and say, oh, this is a weakness and I have some backup plans, right? It's just that you want to be prepared to answer questions if somebody identifies it as being a weakness. Okay, and so that would be the challenge. Okay, so let's start with synthesis. How many people might be interested in doing a hardcore synthesis type of presentation? If not many, then okay, a couple. All right, so I'll go through this, but we'll surely save time for the others. Okay, for anyone who's doing bond forming type of chemistries in your proposal and new ways to form bonds, you want to be sure to know your mechanisms, not just the mechanism of the novel reaction you might be proposing, but the mechanism of anything that's in your proposal. So that includes even simple stuff like protecting groups. How do you put them on? How do you take them off? Okay, all that is fair game for questions in a synthesis-driven OP proposal. Okay, so prepare yourself for those type of questions. And along the way for that, of course, it's almost certain that if you have multi-step synthesis involved, that you will have some acid-base chemistry. So prepare yourself and know or review your basic pKa's. Okay, and so not just the pKa's of strong acids and strong bases, but things that would often form conjugate acids and bases, like protonated form pyridine. What's the pKa of that? Okay, and knowing the relative rankings, the numbers are good, but what's more important is which is more acidic or basic than that second one over there, right? So you have some idea of what the trends are in acidity. And the same thing is true to a certain extent for Lewis acids. What are strong Lewis acids? What are they compatible with? And what are the Lewis bases that might otherwise quench the reactivity of those kind of acids? Okay. Again, oftentimes when you're thinking about this key step, right, whether it's catalysis or synthesis, you want to be able to establish the structure of what you have. Okay, usually it's not going to be a simple structure. It'll be something on the more complex side. What's the right way to establish that you have what you are proposing to get? And for anyone who's taking 560, you know the scope and limitations of NMR. Okay, NMR is not the solve-all for everything. Sometimes if you cannot identify a good way to establish structure, maybe you need to grow a crystal. Okay, so this is these are the sort of things you need to review for yourself. Computation has become very common in both research and OPs. We don't want to be disdainful about computation, but we also don't want you to rely too much on the information that preliminary computation might give you. Okay, think of computation like a form of modeling, right? The old school molecular models we hold on our set, we look at them, we think this is the right conformation and this is how the chemistry should go. Computation is a more advanced version of that, but still it's a model. Okay, and so you can use these as supporting arguments, but and of course you can use those to help identify what you think is going to be interesting, but don't rely too much on it. It's certainly not the ground truth of an actual reaction. Okay, and last but not least, right, the basic information. A lot of these questions often, right, go in a sort of meander all the way down to the basics. So it would be nice if you, for yourself, if you review your notes on Chem 651 and 652. Okay, and that's true again for any sort of OP where, right, the basics are important, and you do get one or two questions very often on those, right, even if they may seem far from your actual proposal. Okay, so let me switch to the second topic. How many people are interested in possibly proposing a bio-related OP? Okay, couple. All right, so let's hear what's involved for that. If you have anything where a biological system's involved, right, cells, bacteria, maybe even organisms, okay, you for sure want to be very clear on the assays that are most important for the candidate molecule that you're interested in, whether it's a probe or a drug. Know what assays are involved in characterizing and basically supporting that you have something good on your hands. Okay, so KD, IC50s, all of these, how do they work? The fundamentals are important. Okay, so don't assume that we know what IC50 is or how MIC50s are. We'll want an explanation. So you should be able to explain, right, how the assays work. Okay, and for any kind of assay you do, be sure to include controls, right, both in your written OP and your presentation. Okay, so the controls are super important for us to see when we are listening to your ideas. This is a generic statement, but I think it's particularly important for a bio-related OP to have the very strong background research so that your hypothesis is clearly defined. Okay, so a bad hypothesis is this new molecule will cure cancer, right? Nobody's going to say that, but right, the idea is that it's just too diffuse, right? You want a hypothesis that's very specific and defined, right? Quantitative would be great. Okay, so rather than just saying that this is going to be a massive improvement in curing this disease or being able to see, right, these kind of tumors, try to be quantitative in your approach, right? We think that this will lead to a tenfold improvement in such and such. Okay, so narrow it down and be as specific as you can. And it's very common for the idea that you want to work on to already have some precedent. Okay, we expect that, in fact. So don't be afraid to go through the background and say, here are all the things that have already been tried up to now. These are successful, relatively successful, and these are not, right? But here's a gap that we've identified. Okay, that would be a great way to present an idea where you're going to introduce in some improvement or maybe even some novelty to a technique. Okay, this is really just to me a common sense statement. But if you're going to work on a particular cellular bacteria, you need to know the details about that cellular bacteria. Okay, so get very intimately familiar with that particular biological system. If it's a protein pathway, the things that are above and below the protein of interest, right, are going to be important because if you knock it out, right, you inhibit it, what downstream effects might that have? Okay, and so, right, biology never works in a vacuum, right? It's always connected to other things, more than other things that we study. So, right, what is the context in which your biological activity is going to be having an effect? Okay, and it's more than just your protein or enzyme of interest. Okay, so related to this is, again, more like number 2, right? Having done your background research, don't be too broad in your scope. Okay, so a bench to bedside proposal is not a good idea, right? You are just leaving yourself open to too many possibilities. You should take, I will recommend that you should take a specific section if you're interested in drug discovery, for example, right? Early stage discovery, right? That has its own set of tools and milestones, right? Drug development, right? You know, doing the med chem on the molecules, right? There's a different sort of philosophy assigned with that and different set of assays. If you want to go into in vivo, right, be sure you know what's involved in going into in vivo, right? It's you know, it is its own sort of research. So please just be cautious and again, just define the boundaries of the biological issue that you want to address, right? When you design something like this. Okay, living subjects are okay. It's just that you have to be prepared to explain what is necessary to know that you have a good outcome. Okay, last one, and it looks like we got a few more minutes. If you are interested in doing something that is materials related, right? So you design something that has some, you know, cool effect or some cool behavior. In a sense, this is very similar to the bio-related proposals. Many of the ideas that we come up with will have some precedent. So just do your background homework and be honest in saying, right, here are the things that have already been done that are related to this, you know, this property that I'm interested in, and here are the things that I think could be improved on. Okay, so being very clear about what your outcome is, right? Quantitative outcomes are the best, right? Instead of just simply saying this is going to, right, change the way that that the Internet of Things works. Okay, so rather be rather specific and don't be too broad. In the same context, when you have a system that you've defined, please be sure to defend what advantages it has over others. Okay, so there's usually, you know, a dozen different ways of being able to get a nice property or effect. Okay, why would your approach be advantageous? In what sense would it be advantageous over, say, the leading brands that might be able to do the same thing? Okay, so very clarify what the value of your particular approach is. Okay, characterization, anything that involves materials, right? There's usually a set of analyses. Okay, it can be very broad. I don't know if you want mechanical, electronic, or optical, but just be prepared to explain how each method works. In this sense, it's very similar to the bio-related proposals, right? You want to know your assays in a bio-related proposal. You want to know your analytical tools for a materials-related proposal, right? What's the basic way that these things work? Okay, and is that particular tool the appropriate one for studying your material property, if that's what you're going after? Okay, and very importantly, what are the limits, right? Not, you know, some tools sound great, but they just can't do everything. So just make sure that the tool that you're interested, the metrology you're interested in, right, is within the correct range of values, right, that you want to go after. It's hard for me to be very specific about this, but just make sure that the tool and the sensitivity levels are appropriate for the things that you want to measure. Okay, one more comment about modeling. Same idea, right? Modeling become very powerful. Again, let's treat it like model. Okay, so computation, great support. Okay, we appreciate seeing it. Don't rely on it too heavily to prove anything, right? It really just gives you color and fleshes out the ideas that you're interested in, right? Any experimental system you want to come up with, you still need to have adequate testing, right? And analysis, right, to show how that works, right? And that's the stuff that I think in an OP we really care about the most. I think that's the last one. So are there any questions related to any of the three topics? So if not, I'm glad to have stopped on time, right, and give Dr. Bart a couple of extra minutes, right, to present her view on things. Thanks very much.
Very good. All right, hi everyone. How are you guys doing? So I'm here to talk to you about the inorganic division's philosophy on the OP. I will tell you that it's a little bit less formal than you're going to see from some of the other divisions. So we don't have like specific formats or templates that we want you to use. It's pretty broad in terms of the category that you can choose from. So we want you to pick something from an area of inorganic chemistry, and that can be broadly defined. The main rule for us in inorganic is that we don't want it to be related to your thesis work. So other divisions don't necessarily have that rule, but for us, we want to see you sort of stretch beyond your thesis project and learn something new. Now, with that being said, it doesn't mean that it can't be related to like a future literature seminar or something like that. So that's okay, but we don't want it to be related to your thesis project. So I'm just going to go through these slides, and this is more broad advice. It's not as specific as what Dr. Wade just presented, but I'll just give you some tips and hints from my time being on OP committees. So the first do I have is to choose something that excites you. Don't choose something that you think we want you to choose. Like, we want you to pick something that you like and that you are excited to learn about and read about. So we do have a graduate student handbook that talks a little bit about the OP. We are working on expanding this with divisional guidelines and things like that, but it is good to talk to your research advisor and your group to learn about things like appropriate length, research relevance, etc. So in the inorganic division, we tell people double space 10 to 15 pages. Definitely come up with a couple ideas and research them simultaneously. Like, don't get set on one topic and decide that you're going to do it without researching it first. So look broadly among a couple areas or a couple topics and then see which ones interest you and which ones you think are going to pan out. Definitely put figures in your report. Nobody wants to read a report that's just words. In fact, I'm pretty sure no one's going to read a report that's just words. So make sure that you use figures appropriately, but also make sure that if there are figures that you have used from an article, that you reference that article. Okay. Make sure you actually propose something. Okay, I know that you're going to think I'm ridiculous for saying this, but I have sat in OPs where the person forgets to propose something. So make sure that you have like well-defined project objectives such that if somebody says to you, hey, what's your OP? You can give them a couple of sentences of what you're actually proposing. It's very easy to get caught up in the background and the literature review and stuff like that. So make sure that you actually have something that you're going to study. And you are definitely allowed to get help from other graduate students and from other professors. So in the inorganic division, your PI is probably not going to talk to you about your OP project, but that doesn't mean that you can't get help from other people, and it doesn't mean you have to do it by yourself. So everybody has a committee. Feel free to meet with those committee members, I guess, and talk to them. And then there's other graduate students, either in your division or in your group or more broadly, but definitely there are people that have done this and have passed it. So seek advice from them. Please have someone proofread your report for you. I know that sounds silly, but just do it. Make a talk that's engaging and recognizable to your report. So of course we want you to make a talk that's interesting because we don't want to be bored when we have to listen to it. But also we want it to be somewhat following your report. So you know you have to hand in your report like 2 weeks early and then you do your presentation. You should not make a new OP in those 2 weeks. You should present the OP you already wrote because you already put all the time in that. And I have been in OPs where it's like a completely new project and I'm like, oh my gosh, like where did this come from? So try to make it recognizable to your report, like use like maybe similar formatting, bring in some of the same figures, the same ideas, like let us know that it is the oral presentation of your written document. You don't need to reinvent the wheel. Practice in front of a group of people. So my students tell me that when they get their friends together and they practice their OP, they usually get harder questions than they did from their committee. So your friends are very smart people and they can really help push you to make your OP better. So invite them to come watch you, buy them some pizza or something. I don't recommend alcohol because you don't want things to get out of hand. Don't get bad advice on your OP. But yeah, pay them off with pizza or something and get them to help you. Also, please dress professionally for your presentation. No jammies, no sweatpants, nothing like that. Yeah, I know, right? You're going to have to get dressed for this. But yes, please dress professionally. Make it seem like you're presenting at a conference or something like that, right? You want to look nice and let us know that you really care about what you're doing. Okay, so here's a list of some don'ts. Don't forget to reference well, okay? Like I said, you can use figures, but make sure that you reference them. We don't want you to accidentally be plagiarizing things. That's not going to look good. Please don't fabricate data to show what the outcome of your proposal would be if you did it. So don't like make up data. We're not supposed to encourage you to make up data. So you can say, oh, if I use this technique, I would expect to see this. But you don't need to make graphs in Excel or something like that to show us, okay? You can talk us through the results that you would expect. Don't make your report a zillion pages. So like I said, in Inorganic, we don't have a specific template. So we usually tell people 10 to 15 spaces or 10 to 15 pages double spaced. Please don't start the week before it's due. This is definitely a project that you want to put some time into. You don't want to rush yourself. You know, you want to carve it up into manageable pieces so that you can do a little bit every day. Like this will be a lot less stressful if you set realistic goals for yourself and try to accomplish those every day versus saying, okay, well, I'm going to sit down today. I'm going to write my OP. Like, don't do that. That's not a good idea. Don't make your talk really long either. So for Inorganic, we usually tell people 20 to 30 minutes because we enjoy interrupting you and making you uncomfortable. So we're going to stop you. We're going to ask you questions. We're going to have discussions. So you don't need to make an hour-long presentation because you will be there all day if you do that. Don't think that you have it and you don't need to practice. You always need to practice. I've been doing this job 15 years. I still practice my talks. Okay, so I practice them on unwilling people. You know, like my kids, they don't want to hear about this stuff anymore. But you always need to practice. Like you can never go wrong with practicing. Like I said, dress professionally. Don't dress like you've rolled out of bed. Don't think you have to do it by yourself. Like I told you before, everybody that's older than you in this department, except for your professors, have gone through this specific OP, right? They've all passed it. They all can give you advice on how to get through it. They can all tell you what worked for them. And maybe you can take some of the tricks, you know, or some of the ideas that they had for how they prepared and use that to help you prepare for yourself. And don't obviously disregard the divisional guidelines. So that's, of course, something that's important, and that's why I'm here telling you about Inorganic. So as you're going to hear from Dr. Lyon and you heard from Dr. Wei, every division kind of has their own spin on things. And in Inorganic, like I said, we have no formatting rules, but we want you to choose a topic that's broadly defined. We want it to not be related to your thesis research, and we would like a report that is about 10 to 15 pages. So that's the general guidelines I always give. Does anybody have any questions about this?
And there's plenty of time for questions, because otherwise we're just going to sit here in silence for a little bit.
That's right. I have 6 minutes. Yes.
I've talked to a couple people who said something along the lines of they had something that they felt very confident in for the written report. And sometime in between those 2 weeks to the oral presentation, they feel like, oh, rare situation.
Yeah, somebody published it,
yeah,
or they all of a sudden have the revelation like, oh crap, this is totally not going to work. Okay,
yeah.
So if that happens, don't panic. All right. The first thing is, if you realize it's not going to work, that's okay. Nobody makes an OP that works. The point is that you go in there, you tell us your idea, tell us why you figured out it's not going to work, and then tell us how you can fix it. Part of this exercise is problem solving. That's what you do as a PhD chemist. You problem solve, right? So if you figure out it's not going to work, don't panic. Figure out why it's not going to work and how you would fix it and work it into your presentation. If somebody publishes it and all of a sudden you find the paper and it's the exact same thing, I mean, you can be honest about that. My guess is it's not going to be exactly the same project, and so you can tell us the difference between what you found and what you actually proposed. So just don't panic. It's okay. We understand that these things happen, but if you're upfront about it and you figure out how to fix it, like, that's really what we want you to be doing. Not panicking is very important. Yes.
What kind of figures have you seen most often, and what's like most useful to supplement?
So for inorganic, I will say lots of chemical reactions so that we understand what reactions you're actually doing. You know, maybe like some theoretical schemes, like a more broad picture. Those are often very useful. You can put in data of related systems, you know, like let's say you're proposing an iron system and somebody already did it on cobalt. You can say like, here's the cobalt data, and this is what they see, and this is what we expect to see on iron. Something like that is fine. You know, so you're allowed to bring the literature into it. We just want to make sure it's well referenced. But I'd say figures like that are probably the most common. I mean, if you do bio-inorganic, like you can put in proteins and stuff. That seems important if you're doing bio-inorganic, right? I don't know. They're all just curly to me, but that's why I'm a synthetic and organic chemist, right? So, yeah. So, you know, if you're working on certain protein systems, you want to put in background about that. You know, just anything that you need to make your points. And, you know, the better you do at choosing the pictures, the less writing you have to do, right? So if you have really effective pictures, then you can, you know, it'll come across more clearly. Yeah. Anybody else? All right. Well, I will let Dr. Lyon take over from here.
Good that you get 2.5 extra. Oh my goodness. To explain the NIH format. All right. So in contrast to Dr. Bart's presentation, we have a strict format in biochemistry. You may love it or hate it, but if you continue in any sort of biomedical research, it is your life. Okay, so first off, how do you plan your topic? So your research plan needs to be hypothesis driven. You need to be trying to answer a particular question and be specific, not something like I'm going to understand how cancer occurs in the lung. That is not helpful. That is more work than anyone could ever do in their entire life. It needs to be clear and it needs to be informative. So as you think about topics, and you can get ideas from your classes, from seminars, from your friends' labs, as long as it is not your own thesis project, you want to think about novelty. So taking an interaction between two proteins that happens in neurons in zebrafish and doing the exact same thing in skin cells, not going to fly. That is too safe. That could be like step 1A, and then you're going to go do something different. But doing something that's already been done in one system and just changing the cell type is not sufficient. Significance, make sure it's an actual real problem. You can convince us that in your writing if it's something that you care about. And then feasible. So don't propose that you're going to cure a disease. You can answer a very specific question, but you do need to have defined end goals. And then as you organize your OP, and I'll get into the format in a few minutes, you need to think about and convince us why what you're proposing is important. So the very first question that I ask my own students when they're presenting is, why should I care? You've got to convince me and your committee why we should care about your topic right off the bat. What's already been done? What is the background of your system, and what are you going to add on to it? What do you intend to do, and why is it novel or special or different or important? And then how are you going to do the work? And how is very important. And we're going to spend a lot of time talking about that. Okay, so Biochem format has to be in an NIH style proposal. That means that you will use Arial or Helvetica font. It needs to be black and it needs to be 11 points or larger. You can have 10 to 12 single spaced pages max. That includes all of your figures and all of your figure captions. You don't have to use all of that though. This is just the max amount. The specific aims, which is a separate page. It's a one-page summary of your entire grant, and the references are not included. So you have one-page specific aims, however many references you have, and then a 10 to 12-page proposal. If you want to see examples of that, just Google NIH proposals, and you can find tons and tons of examples. So the specific aims page is a one-page overview that states the goals of the proposed research, the expected outcomes, and the impact of the results. So why should I care? What's known? What are you doing? And why is it important? And then how exactly are you going to answer those things? And at the end of it, what did we learn? So the aims page is totally separate from the whole proposal. I strongly encourage you to write your proposal and then write the specific aims page. You will save yourself a lot of frustration. Typically, proposals usually have 2 specific aims. I get asked a lot if you have to have 3. No, I don't know why everyone does 3 aims. You don't have to. I think it just sounds like a good number. 2 good aims that are related but independent of one another, so you could do aim 1 and aim 2 at the same time. That is far better than a good aim 1, an okay aim 2, and then a whimper of an aim 3. So you don't have to be a hero. 2 aims is more than enough. Okay, so specific aims. Again, write that separately. So the actual meat of your proposal is called the research strategy, and this is further broken down into different sections. So first off is background and significance. This is usually a page or 2, and that's where you convince us to care. So what's the background? What's the state of the field? What do we know? And then at the end of that, what are the big questions left to answer? And that's where your OP proposal comes into play. And then when you're writing this section, especially at the end, you need to make it very clear how your proposal addresses these gaps and what you're going to add to the field. Some people, and this is not a required section, but you can take a stab at it if you want, is innovation. This is usually a short paragraph. In most biological, biochemistry, chemical biology research, you know, a lot of what we do is not necessarily like tool development or coming up with new methodologies or new theoretical concepts or instrumentation. It's really the knowledge that you're contributing or you're using existing techniques in a new way. So it doesn't have to be, you can have an innovation section without inventing a new type of instrument or new software or something like that. And then what you will spend the overwhelming majority of your time on is the approach. So this is the research strategy, what you're going to do, the types of experiments you're going to do, what the results will look like, how data is going to be collected and analyzed, what controls you're using, and potential problems. So one of the things that I always like to ask in an OP is what happens if everything fails? What have you learned? You have to have backup plans, and you should write your proposal such that even if your favorite hypothesis is wrong, you've still learned something meaningful that contributes to the field. So you can, so again, this is a little different from the inorganic division, but you can include expected data and results. So this could be a very similar experiment that's already been published, and you're just kind of showing general trends. It can be something that you made in BioRender. Everybody likes to use BioRender now. Or you can just make your own bar graph, basically. If you don't show us what the data is going to look like, we will ask you to draw it. And this is because, you know, we don't have nice synthetic schemes where A goes to B goes to C. A lot of times we're doing something weird to a cell and things change a little bit. What does that look like and what does that mean? So background and significance, why I should care and what you're going to do. Innovation, what makes your proposal special. And then approach is basically a hardcore lab report. Okay, so general tips. This should not be an incremental step forward. Again, you don't want to play it too safe, but at the same time, you're not going to convince any of us that this is a feasible proposal if you're going to cure a disease. So keep that in mind. Again, don't cure a disease, and there's nothing magical about 3 specific aims. The first grant I ever got funded was 2 aims, so NIH doesn't care. You absolutely have to include control experiments and backup plans. So if you take a look at most NIH grants, what's really common is after each aim, there will be a section called potential problems and alternative approaches. This is usually a pretty short paragraph. What could go wrong? Where are the biggest issues that you see, like a technical difficulty that you'll have to overcome? Point that out, and then how you're going to get around it. So that, and you can have as many potential problems and alternative approaches as you need, but if you don't include them, you will be asked about it. So let me back up. Ask your peers for examples of their successful OPs and for help. So again, you are not doing this on your own. Nobody expects you to do this on your own. That would be horrible. You can ask anybody to help you except your major advisor. Other PIs, I have students from other divisions and other departments ask me questions related to their OP. It's not weird. Don't feel bad. You're learning. You can ask other graduate students. You know, everyone wants you to succeed, so you might as well get as much help as you can stand. Everything in your proposal or presentation is fair game for questions. Do not show something on a slide if you are not prepared to explain what it is. If that means putting white boxes on things that you don't want us to look at, that's fine. You want to make your own figure, that's fine. But if it's in your document or if it's on a slide, that means that you are prepared to explain it and answer questions about it. Be clear and concise. So, and again, similar to Inorganic, prepare a 20 to 30 minute presentation, but you will be interrupted. And most of the time, questions are curiosity. You know, tell us more about this. I don't understand how this works, or I thought this is the way this worked. You know, a good OP is more of a discussion between you and your committee members. You can absolutely prepare backup slides for questions that you expect. So you want to set yourself up for like a nice softball question, like, okay, everyone keeps asking me this one thing when I practice. I'm going to put it on a backup slide. And then you can flip to that and be like, yeah, I know what I'm talking about. Like, we're on this. So totally fine. Most people usually end up having, I would say, 10 to 15 backup slides. You're not necessarily going to use them. It's kind of a safety net. It makes you feel good, but you also might be able to show one as needed. Okay, so that's the biochemistry format. And there's also a handout or PDF that you can take a look at. And that goes into a little bit more detail about what some of these different sections look like. Questions?
Also, if you didn't get the handout, because I might not have written it up, feel free to just reply to the email that I sent out, and I'll send you a PDF of the file.
Yeah, one thing, for better or for worse, the NIH format is helpful in structuring the way that you think about things. Within each big section, though, so background and significance, innovation, research strategy, how you organize that within each section is up to you. There's not a right or wrong answer. It's whatever makes sense to you as you tell the story. Eric.
Some of the people I've talked to who've done their OPs, they've said that you really kind of want to be as like short as you can make it without like kind of removing like key things. Like it's recommended you don't go all the way to the max limit because you might bore your committee apparently. I just want to know, like, you said like 10-ish pages is the max. Is there kind of an informal minimum?
Most people, well, most of the proposals I see are 12 pages. You don't have to do half-inch margins. You can do 1-inch margins. You can do 12-point font. Those are just like, if you're writing a real R01, then you will use half-inch margins and 11-point font. But it doesn't have to be that way. It just can't be smaller than that. We like figures. Figures save you writing. Make your own, put boxes on stuff. Yes? So the biggest things that I see are not thinking about controls. So you're going to do some sort of treatment. Maybe you're going to make mutants, or you're going to transfect something or knock something out. You have to have the controls for all of that. You've got to beat up your cells the same way, whether or not you're putting in a particular gene or RNA or whatever. So you need to think about, what am I doing? What are all the ways that I could make my cells or my system or my organism unhappy? And then make sure you have a condition where you do that. That's probably the biggest thing. Having backup methods or other ways of answering a question is another place where people often struggle. If you can get at something, just because you can CRISPR out a gene to look at its function doesn't mean you shouldn't knock it out another way. So having more than one way to test a hypothesis is really good. And that can also go into your potential problems, alternative approaches, right? Backup plans for backup plans. And then finally, another thing that often seems to happen, or has happened more often, is playing things too safe. So one type of experiment where it's one experiment and then you're just changing, the drug you put on the cell, or you're looking at knocking out a particular gene and doing the same assay over and over again. That's one aim, part of one aim, but you need to have distinct questions that you're asking. So aim 1 needs to be one question, aim 2 needs to be another, and together you're going to answer this bigger thing. You don't want to be in a situation where you can only do aim 2 if aim 1 works exactly the way you want. So as you write, one way to think about that is to have them as standalone things in your own head. Like, yeah, they're related to one another, but if aim 1 is a total disaster and everything is different from what I expect, that's okay. I can still do aim 2. Oh, you're welcome. Other questions? Yeah.
I know the other submissions really require you to have a key that's very different from your research. Is that the same with biochemistry? Like, what are the limits on that?
So what I tell people is that it definitely cannot be your thesis work. The closer it is to your research or the research that your lab does, the more we expect you to know about the background. So if you pick something that's very similar to what your lab mate does, then we expect you to know a lot about it, because you've spent all of your research career, or most of it so far, working on that general area. So if you stick close to home, you're going to have a lot of questions. If you venture to something totally different, you still get a lot of questions, but it's not the same level of detail. So it's really personal preference. You can take all the techniques and apply them to a totally different system. A lot of people do that. Or maybe you work in a very reductionist system where you're working with purified things and you go into cells, or vice versa, right? You're still answering similar questions, you're just using a different format to answer them. Don't wait till the last minute. Please don't. We can always tell. Any other questions? All right.
Well, thank you, Dr. White.
If you think of more things, you can shoot me an email, talk to any of the biochem faculty. We want you to do well.
Yeah, we'll get started immediately. So.
And the slides are here?
Yes.
Okay, great. Good. Hi, everyone. I heard a little bit about the last presentation, and I found also a list here from Professor Bartz. So it's interesting, maybe now, if there's time to compare and contrast with those. So I only brought 2 slides. The first one on what is expected for OPs in the physical chemistry division, and the second on a few hopefully helpful preparation tips. Just out of curiosity, how many of you are planning to take a physical chemistry OP? Okay, so especially to you. And for the others, maybe fun to compare. and see what you missed by not choosing the pick and division. And it will be, for example, in Biochem there are two aims, right? There's just one aim in pick. I see in Inorganic you need to dress appropriately and professionally. In Biochem you don't have to dress appropriately. So you can switch. Okay, so what is expected? So here I have in gray, note specific expectations may vary among faculty. And that's important. It's similar to what happens in actual review panels in NSF. Everyone in the panel has a different expectation, and so it's difficult to write something that will convince everyone, and that's part of the challenge, right? It has to be foolproof. If there's a weakness, maybe no one will catch it, but maybe someone will. If there are no weaknesses, then everyone will be convinced. Okay, note number 2. So specific expectations may vary, but the general expectations are the same for all. The OP in physical chemistry should be original, interesting, and generally correct. From the written document and the oral presentation, it should be clear that you have studied well an area not directly linked to your PhD project, and you can clearly identify and state one concrete problem that you are proposing to solve. It could also be 2, but then it gets too complicated sometimes when it's 2. We prefer 1. And that you have studied and understood the fundamental Biochem principles that provide appropriate background or context for your proposal. So if you choose to do something in, I don't know, kinetics, then you should be really strong on kinetics. And so depending on what the main topic is on your OP, the fundamentals have to be clear, because sometimes it turns a little bit into an exam, an oral exam, and we ask basic questions about the physical chemistry underlying what you're saying. And 3, you have given some serious thought to how you would attempt to solve or approach the problem and what the main challenges are. This is similar to what Angeline was saying about there are always questions on what happens if this doesn't work, what are the main challenges here or there, what can go wrong. Okay, so that's all for what's expected. And now I have a slide here on some tips. And the first one that I wanted to tell you is you need to be genuinely interested and try to convey your excitement to the committee. And I swear I had not seen Suzanne's list, and that's also her first point here. Choose a topic that interests and excites you. I really think that's the most important one. It's very difficult to not be interested in something and make others interested in that, right? You have to be interested yourself. And then it may be just a gut feeling that you find a topic really interesting and you don't really know why. So you can maybe spend some time talking to yourself. So why is it, try to pin down why you find the topic interesting, and then explain this as best as possible to the committee. This one is an important one in Biochem OPs, because you always, or very often, it's a common weakness. So it's a common error, let's say, that there are either in your written document or in the presentation some word or some plot or some comment, either in the written document or the slides, that you don't know how to define properly, and that can lead to issues, right? So every word, plot, comment, you need to be ready to explain. And so that, in general, goes with slides that are not too crowded, because the probability of having something that you cannot defend in a crowded slide is higher. So simpler slides, less text. Things that are not necessary are typically distracting and may lead to these types of issues. So if something is not necessary to make your point, just don't include it. And here I also see a big coincidence here. Practicing was a major thing in Dr. Bart's tips, the same here. And when practicing, put yourself in the shoes of someone who is listening to your presentation for the first time, committee members, and will want to know whether the speaker has a clear proposal in mind. So once you have your OP ready, this is a good exercise. You pretend that you are your committee member and take it seriously. Maybe record your talk and then you pretend you are in the committee and try to find your own issues here. Ask yourself whether you know the meaning of everything you are showing on your slides. Strive for clarity. And when you are practicing in that way, be impatient to get to the main point, because the committee will typically be impatient to know what the main point is, and they will be trying to figure this out from the beginning. So, okay, so what's the main point? What is this about? And why is it interesting and important? So, this is not a requirement, but it's maybe a good idea to have one slide that clearly states the problem you are proposing to solve and why. And maybe this is the slide where most of the work should go into. Because once you have this slide, then everything else will follow and can be used to support your OP. And this has a little bit to do with what you were discussing at the end of the last talk with a question. You may have chosen a topic that's so far removed from you that no one in the room knows much about. And that's fine. But it raises also some special challenges. The committee will be asking questions that go to probing the overall logic, and it's sometimes easy to find logical gaps that then lead to some issues with the OP. Finally, not a problem to make a few mistakes or to say a few things that are incorrect. The problem more is to not recognize this. You can see this sometimes, and then you try to confuse the committee, and that sometimes works and sometimes it doesn't. And I think that's everything that I have. Yeah, that's pretty quick. So if you have questions, then I'm happy to try and answer, or else we can go over Professor Bart's tips again, one by one, and compare and see if they apply to Pickens. That should be fun. Could we do that?
Sure.
Okay. So I see that I like this. It was divided into do's and don'ts. And so this is review of inorganic, for those of you in inorganic. Choose a topic that interests and excites you. Yes, okay. Do ask your research advisor or check the graduate student handbook to see what the divisional guidelines are, appropriate length, research relevance, etc. Yes, and the answer in Pickens is that we don't have, actually we don't have very clear we don't have very clear guidelines. I like this idea of the NIH format. So maybe we should do something similar. Not NIH, obviously, but maybe DOE or NSF or something like that. You like that idea? Or okay, I don't know. It's not bad, because one of the main things about this OP is to practice for, especially if you go later into an academic position and you will be applying for grants to external funding, to as a practice for a real proposal. And so formatting is important. If you send it with the wrong formatting, it will bounce back. Am I going over time?
Oh, no, you're plenty of time,
Okay.
yeah.
Come up with a few ideas and spend time researching simultaneously. Yes, okay, yes, come up with a few ideas. It's typically so hard to come up with one good idea that I don't know how you come up with a few. But I guess you try a few ones and then you select the one that's the best. Use figures to make your report interesting and effective. Completely agree. Figures are always good also in Pica. Make sure you actually propose something. I like these a lot more than mine. Yes, it happens sometimes that you read an OP and at the end you have no idea what's being proposed. There's a lot of text and figures but no actual proposal, and that's not so. You enter into the OP room in a bad mood if that happens. If there's nothing proposed. Seek help from older graduate students and other professors. Yes. Ask someone to proofread your report for you. I like that. Make a talk that is engaging and recognizable to your report. Yeah. Practice, yes. Dress professionally. Not necessary. So there's only one out of many that's not the same. So it seems like there's a lot of overlap with inorganic. Don't forget to reference the work of others. Very important. Don't fabricate data. I think that's, to show what the outcome of your proposal would be if you actually did it. Oh, I see, right. Yeah, I think it's better not to, sometimes people do cartoons to show how the data would look like if you did the experiment. This is of course not, this is not plagiarism, this is not a good idea. Yeah. Don't make your report a zillion pages. Absolutely, yes. The shorter, the briefer, the better. Don't start your report the week before it's due. Don't make your talk really long. Don't think you have it and don't need to practice. Don't rest like you're rolled out of bed. Don't think you have to do it by yourself and cannot get input from others. Don't disregard the guide. I shouldn't have. Professor Bart's tips are the best here for Pica.
Okay, are there any last-minute questions for Dr. Wasserman? I guess we'll just go with the one general one that probably anybody would want to know. What are some of the most frustrating mistakes that students make during their OP?
I'm just talking, but he didn't make any, so it's not a good example. Yeah. This is one that bothers me personally. When someone makes you see something that's wrong, and then you try and pretend to just like mask it somehow and with lack of clarity, and so that's most common mistake. No, okay, I know. The most common mistake is this one here. You're talking about a partition function, and then someone asks what is a partition function, and you cannot define it. Right. Yeah. I don't mean the partition function in particular, but just something that you cannot define.
Okay. Well, thank you very much, Dr. Wasserman.
Thank you.
All right. I don't think anybody's going to come straggling in at the last minute, so we will move on to Dr. Laskin. I do have your slides up here. I don't know what you prefer, but They're after your group photo.
There's
Oh,
a list
you have my
here.
slides, right?
Yeah.
So
Yeah,
they're
these
right
are
after the group photo. Oh, okay. That was just in case we had
I
it
found
early.
this list here
Uh-huh.
of Susan's
Oh,
do's
okay.
and don'ts,
Uh-huh.
and I had plenty of time, so I went over them to compare inorganic with clicking on this pretty fast to compare.
Uh-huh.
Yeah.
Uh-huh. Okay.
You just can
I'll
this
look
is
at that
analytical,
too.
yeah.
Okay.
Great. Thank you very much.
Thank you. All right. So, okay. So let me see. Tell you my insight, my perspective on OP in the analytical division. So the idea is for you to demonstrate that you can think independently, you can design a project independently, and you can learn by reading literature. You can learn about a field that is not your field of research, that you can critically evaluate this field that you're reading about and identify certain knowledge gaps in that field, and that you can take this idea from the very beginning to the end and figure out, come up with your solution to address a specific knowledge gap and communicate this idea to your committee, both orally and in writing. So you will be evaluated. You just think about, your committee members. Nobody wants to fail you, but we're curious scientists, and we'll be asking questions, trying to understand what exactly is your idea, what exactly do you mean, what else is known, and so you will get a lot of kind of curiosity-driven questions about your idea. So we're usually a friendly group of curious people, and you have to satisfy that curiosity, okay? So that, I guess, is a challenge, right? So the passing rate is high in the analytical division, but that's usually because our students put a lot of effort into OP, so they come very much prepared, and they do well. There are cases when you will get a conditional pass, okay? Don't consider that a failure. You will feel down, you will feel like, oh my gosh, I failed my OP. Usually you are given some kind of assignment, okay? So if your committee was not satisfied with something, they will give you an assignment and tell you, okay, so do this, convince us that this and this works, and add some additional document, write an additional 1 or 2 pages of summary, and submit it to your committee members. So don't feel that you failed your OP. Don't go and drown in tears after that. Just take it as, okay, this is a way for me to really deal with it. There is a clear action item. I can do that. I can read a little more. I can write a little bit. I can think about this question that I was asked. So just take it, on a kind of actionable side. Okay, I know it's a lot of that is emotional, but just in general, at least I haven't seen anybody who, after conditional pass, did not pass their OP. So not to say that it never happened, right? But in general, right? So just don't see it as your failure. So most of the questions that you will get will be driven by the desire to understand your idea, and also understand that you stand on your feet, right? So you just have to make sure that you understand every aspect of your idea that you're proposing. And that means that it has to be reasonably focused, okay? So you can't just be proposing everything. So think about, when we write proposals, we write a proposal for a single investigator. You write a proposal that with the goals that can be accomplished, say, in 3 years. So that should be your kind of thinking. If I worked on this project for 3 years, what could I have accomplished? So it can't be too broad. In particular, if your idea is too broad, you also you have to be able to defend every aspect. So if your idea is very broad, you'll have to be defending pretty much on every front, right? And that sometimes you will find that you just lack depth on every front of your idea, right? So just focus your idea, make sure that you have a focus topic. Um, so even things that are mentioned in your introduction sometimes require to kind of you may get questions about that. So you say, for example, well, fluorescence microscopy is commonly used to study, the dynamics of cells or something along those lines. You may get a question, and how is that used? How is fluorescence microscopy used? And it may not be even the subject of your OP. But if you are comparing your approach to other techniques or your field to other fields, in your introduction, you may get questions about that other field that you may have not studied. So just think, carefully about what you include and what you don't include in your presentation and in your write-up. So where would I start? I didn't have to do my OP, so you have to. But thinking about where would I have started, right? I would go to review articles and just recent reviews in major journals. Analytical chemistry is fantastic. Open a January issue of any year of analytical chemistry. It has short reviews, so you don't have to read like forever, right? So if you go to chemical reviews, you will have comprehensive reviews, like 50 pages with 400 citations or more. That's a huge task to read a lot of reviews, right? That are comprehensive. So just go to short reviews. Annual reviews in analytical chemistry are usually quite short. Analytical chemistry January issue, usually short reviews. Analyst has some review articles. Trends in analytical chemistry are short review articles. So you have a lot of different accounts of chemical research, by the way, is also, they're not reviews, they're perspectives, so maybe more in-depth insights into one person's field, okay? Find a topic that interests you, right? So you have to like what you're working on. If you hate the topic, you will not make a compelling presentation. You will not, if you don't like it enough, put it this way, if you don't care about the topic, it's hard to make it interesting for others too. So find what interests you, identify gaps and challenges, propose solution, make sure it has not been done, and then propose a series of aims that will address this gap and that will resolve this issue that you found. My strong recommendation of focusing on chemistry and analytical chemistry. So we have people go far into physics, far into sometimes computational sciences, far into biology. So the farther away you go from analytical chemistry, the weirder will be the questions that you will get, just because we're not experts in biology, we're not experts in in physics. So you'll get some really weird questions, and I would say, it will benefit you too more if you focused on analytical chemistry. You have to select a topic that's far enough from your research. So the closer you are to your research area, the more scrutiny there will be on novelty and feasibility and innovation of your approach. So just step aside to the area that is far enough from your research. There is still, of course, we still want to see innovation and novelty there, but if your idea is really original outside of your area of research, it will be appreciated from the beginning, okay? So it will give you a good, good head start with the committee. So this is just a slide, and you can have it. I'm not going to read through that. So this is my proposed structure of the written proposal. So I think it shouldn't be more than 6 pages long. It can be longer if you like writing, but if you're writing many more than 6 pages, you're probably going too far. So there is a short kind of, they're called R21 proposals for NIH, where you don't have preliminary data, but you just have an idea. And so those are 6-page proposals. In 6 pages, you have to tell everybody everything they have to know about your proposed work, and you don't have an opportunity to defend it either. So you have to put a compelling story in about 6 pages, and I think that's worth an effort. So define your objectives. So about 2-3 sentences of your goals of your proposal. Tell us what's significant, what's known in background and significance. It's always good to have specific aims. So define your maybe three specific aims is a good number. Explain your specific aims. They have to be somehow measurable. There should be measurable outcomes of specific aims. And then describe how you approach this problem. Give a brief summary, just maybe in 1 or 2 paragraphs, and references. If you can find copies of proposals, NSF or NIH proposals of from your research group, that's always a good kind of a good document to have to kind of reference yourself. How are the proposals written in general, right? How do I go about that? And I'm sure your PIs will be happy to share documents with you so that you can actually have, kind of a starting point, at least to see how is that written, how does it look like. So so that's for the written document. For the exam, prepare slides for about 20 to 30-minute presentation. That's not counting questions. Be prepared to be interrupted all the time, okay? But if you have about 20 to 30-minute presentation, usually you will be finished in about an hour. So you just need to make sure that you get to the end of your story. Use figures from literature. Make sure the figures look good. Everything is legible. Things are readable. You use fonts that, people can read. Just make slides that, hopefully you learn from your seminars or will learn from your seminars how to make good slides. If you want to use some simulations, calculations, estimations, please do. But don't try to make up data. You can simulate data based on what you know, but you cannot make up any data. So use literature as your background data. Everything you put on your slides is a fair game. Okay, so if you so whatever technique that you're proposing to use, or even whatever technique you mentioned in the introduction, may result in some questions. So you just need to be prepared to defend everything that's on your slides. Have some backup slides that you can use to answer questions, so you have to convey what's known, keep it short. Tell us what's novel about your proposal. Tell what experiments will you perform in what sequence and why. What is the outcome of your experiments? What is the outcome of your proposal? And at the end, be prepared to talk maybe for like 5-ish minutes, 10 minutes maybe about your own research. Sometimes you're asked to do that. Sometimes you're not asked to do that. But just have slides for maybe 5 to 10 minutes of your own research summary. But also don't be offended if you're not asked to show them, okay? So it depends. That's all I had to say, and I'm happy to answer any questions you may have. Yes?
What's an example of a conditional class, and do we have to defend, again?
There are cases when you're asked to defend again. If the presentation really didn't go well, then you may be asked to defend again. I haven't experienced that yet, but I've heard about cases when people were asked to defend again.
In that case, you have to pick a different topic and everything?
Well, that may be also the case. That may be the case. But usually conditional pass is when you have a certain really important point in your proposal that you cannot defend. And you will be asked to defend that particular point. Convince us that this is feasible, for example. Use literature to convince your committee members that X and Y is feasible.
So
Some-
is that
something
based
or
on
calculations.
the paper that we have to write?
You write a document, yeah, maybe like a 1-2 page document to kind of as an amendment to your OP, and your committee members read the document, and if they're satisfied with the answers, it's good, and you pass. Yes.
What common mistakes do you see in OPs in the analytical position?
Common mistakes, having things on slides that you don't know what they are really. So bringing in a technique that you don't know how it works. Claiming that you will make a measurement using this technique without understanding how the technique works. Things like that. Sometimes not thinking about the conceptual questions. So is the solution phase chemistry even right for this experiment? Things like that, right? Do you have to worry about the pH, or you know, or if you have to worry, in what way, right? Can you predict different species that you will have a different pH, if that applies to your particular idea, right? For example, things like that. So conceptually, you're not kind of you're not defending. Your idea in terms of, oh, maybe this will not work because this molecule at this pH will be like in this form, and then it won't fluoresce, that kind of thing, you know? So you just have to think about whether or not your experiment design works, and not just based on, oh, it worked in this paper and it will work for me. But what's the underlying chemistry? Like, why did it work in that paper, really? So you may be asked about, more kind of in-depth questions.
Thank you.
Poor slides, we see a lot of poorly made slides, with like really tiny fonts where nobody can read what's on your slide. Things like that, just the presentation itself, wordy slides. So yeah, that probably is quite common issues.
Thank you.
Okay, are there any other questions for Dr. Laskin? No? All right. Well, thank you very much, Dr. Laskin.
Yeah, best of
We're
luck.
really
Do
happy to be here.
you mind if I take this from you?
Oh, go ahead, absolutely. So now we're going to move on to our graduate student panel. I just want to reiterate the fact that if this is being recorded, it will be up on Iota Sigma Pi's YouTube channel. It'll be sent out as a link. So if you want to review anything, feel free. And if you didn't get the handout, again, just reply to my email and let me know. I'll send you a copy of any of the handouts that you want. So we'll bring up our 5 lovely volunteers. They're hiding in the back of the room. I'm just going to chill at the computer. Yeah, you're on the internet. I can Google you. But yeah, we do have a representative from each division. If anyone has questions off the bat, we'll start like that. If not, I have some like warm-up questions I can throw at them. But does anyone have any while they're getting? Okay, cool, Sonia, we'll start with you.
It kind of seems silly, but for analytical division, do we have to dress up?
I mean, yeah, it's kind of like what you would wear to a conference, like business casual. I mean, I wore like jeans / dress pants that were black and just like a nice shirt and boots.
We had a physical professor who came in and said you don't really have to dress up.
I mean, don't also wear anything you're uncomfortable with because you could be standing for a while. So like, don't wear heels if you know you're going to be uncomfortable in them.
Yeah.
Generally, it is good to pick a topic that your committee knows a lot about or something they don't know very well.
I don't think you should be, I don't know, at least for me personally, I think pick a topic based on like what my committee knows or not. I think you should focus on what you think you will know the best, because you'll be the one presenting to them anyways. They're not gonna like they're gonna test you on your knowledge, not basically on what they know, if that makes sense. So That's just my advice, but.
I agree, and you should also be wary of if you end up picking a topic they're very fluent in, expect them to really know a lot and to really push you. So I would really, like just start off with the topic you like, and then just kind of be cautious what that settles on. But I wouldn't deliberately go for one of their interests. It's going to be a lot harder, probably.
Yeah.
How did you guys approach the OP? How did you guys end up finding that topic?
So what Dr. Laskin was talking about on the articles, that's what I did. So like I used the Council of Chemical Research, and I like read through a couple and I like narrowed it down to like a couple of ideas that I had. And so then I went off of there and like found different papers, like what was going on. Really my biggest like strategy was to look at the end of papers and then be like, oh, this is like what we could do, or like, oh, but there's questions about this. But I started with the Accounts of Chemical Review, went to what I thought was cool, and then yeah, from there, the papers that I read, I was like, okay, what's been done? What are these people that are like smart in this field saying that could be done? And that's how I did it.
For me, it was go to reviews, some kind of like more broad review of some topic that I had interest in. Like I looked at like organic division with some like inorganic aspects is what I do. So it was like low valent metal catalysis, stuff like that, and just kind of pick through a bunch of reviews until I found like an idea that I could kind of like get from mushing a few other concepts together.
Okay, for me, it's like there are always a lot of thoughts and ideas going on in my mind, which I do not have enough time to do research on. But OP is a good opportunity, right? I just pick randomly one of them and write something about it. Yeah.
I have one question, I guess, for all of you. How long did you spend on prepping your OP?
You mean
Like from the moment you come up with the idea?
it's like 2 months
Okay.
for me. You want to start as early as you can.
Okay.
I guess an additional question is how many topics did you go through when trying to actually land on one? Was it your first idea, or did you go through several before finally landing on a topic? Just a general question for all y'all.
For me, how I actually approached BOP, and that kind of falls with that, is I started actually with topics I generally was interested in. So I was like, for me personally, I was interested in space and mental health, and I realized a lot of space documents are super classified, so getting detailed information was going to be difficult. So then I was kind of like, well, let's explore the mental health field, and so I just started reading like analytical review papers, and so from there I actually just kind of narrowed down my topic, so I never technically switched topic. I just had a broad interest, and then I just kept reading until I found a gap and then something I could fill. So I think also if you're really interested and passionate about the topic, it really helps, because then when you're reading like article after article, for me at least, I was genuinely curious about it and I found it really interesting. So yeah, but people do, I know, go through many topics. It really just depends.
Yeah, I just went through several topics because in PChem division they're requiring that your OP has to be unrelated to your current research project. So I just made a list. I made a list of all the topics which I was interested in, like 4 to 5 topics maybe in different subfields of PChem, other than DFT, which is my major project. So I just went through like number 1 to number 5 and to find like the most comfortable one for me to write something on.
Yeah, I had a topic that was like water related catalysis, and I like mentioned it to some of the senior lab members, and they were like, that topic's been like beaten to death, and like nobody's like made any progress on it. So like, do you really think you could do anything in it? Which was like good for me to hear, because then I was like, oh well, like I can't really do anything realistically there. So then I went to a more like niche topic, because one, I wasn't too committed to the first one, but so I guess I went through 2. But with that, I guess like your lab mates, your older senior lab mates are like your biggest help, because one, they know what your advisor's like inside an OP, and they can kind of give you an idea of like, you know, not how lenient they are, but like what kind of questions they ask and like how much are they willing to like help you out. Because at the end of the day, your PI wants you to pass because they're like putting money and time into you. So just ask your senior lab members, like give them like ideas, like this is what I think about doing. Is that something that you think you guys could help me with? To like push you, because a lot of times what you end up doing is practicing your OP in front of your lab mates, and if they have like an interest in it, they can help you better. That's not saying like rely on something that you're like on your senior lab members to give you the topic, but just for them to like push you around and press on it, because especially when you have fifth years, they're almost like PhDs, so they know like the kinds of questions that like a PI would be asking.
Well, do you want to just ask a question?
No, you can go first.
I got kind of lucky with mine. Pretty much the first review I really read, I got my concept and then kind of worked it from there. So it didn't really take me much time to get that idea down in the first place. So yeah, it's kind of lucky.
Like for me, I just had like a broad idea of like I knew I wanted to do it on malaria, for example, but I didn't know like what questions I wanted to answer. So I did write my first aims, like my first aim page, but then 2 weeks later, I completely changed my mind and then switched like the questions I wanted to answer. So I had a broad idea of the topic, but the questions I was trying to answer was kind of different. And I went with my second idea. And again, talking to your senior lab members also helped.
Okay. On the presentation, how long in did you get before they started just bombarding questions? And do you guys also remember any questions that were like, oh, I didn't actually have a good answer for that. I wasn't prepared for that.
Yeah, definitely the first slide. So I did MRI contrast agents, and as Dr. Laskin, I heard her say like anything is fair game. So like what I was focused on was like the contrast agents and like designing them. But the question, I had a picture just for like funsies of like an MRI image, and like the first question that was asked was like, how do they administer the drug? And so like that's something I don't know. And so like I gave a really stupid answer because it was like of a cranium, and I was like, oh, they inject it on site. And my committee member was like, oh, so they like inject the needle into your brain? And I was like, yes. That's not very right. So yes, it was a very bad answer. It was a very easy question that I missed. But again, it was just a matter of like, you say it, you move on. Like if you think you said a question wrong, don't like get stuck on it, because then if they see that you're struggling, they're gonna that's easy like fruit picking for them to be like, oh, it's like they're struggling here, not because they're being mean, but because they want to like push you to like see. A lot of times it's not really giving the right answer, but like your thought process. Like if you can speak out loud and say like, okay, I think this, then that, that way they hear that you're actually thinking through it. So if you do get a question wrong, you're like, oh, that's really dumb. Just like move on. Like don't stress about it, because you already have enough stress to worry about. So
Kind of piggybacking on that, whatever you put on your slides, you need to make sure you put it for a reason, and you like know everything about what you put, because like was mentioned, everything is fair game. So if it's on there, you need to be able to defend any part of it.
Yeah, so that means you actually have a lot of power in that sense, because you kind of choose how much you want to reveal. So if you're going to start throwing a lot of detailed information, you're leaving yourself open to way more questions. So it's really in your best interest to really try to dictate at least how you want to present things and what you want to present, such that they kind of stay in a more narrow and straight line. On the topic of questions also, one really important thing is prior, you should really consider what are the weaknesses of your proposal. And just because there's weaknesses and drawbacks, that doesn't make it a bad idea. It just means like, yeah, there's issues, but this is still something worth pursuing. Like that's kind of the general mindset, and you should absolutely be willing to admit it. Like if somebody would bring up something during mine, like, oh yeah, like this would be difficult to do, I'd be like, yeah, absolutely, but for what like we're trying to solve in this case, like it's probably our best option for now. That type of mindset they really appreciate, because if you fiercely defend your topic, especially if it's really not that great, they're really going to kind of view you as almost ignorant to what the value of everything is.
Okay, for PCAM, the difficult questions usually like they pop up in the middle where you are doing the presentation, and I would say mostly they are about the equations. So it's really important that you fully understand the logic of the derivation and formulation. So, like in my case, Dr. Kais just asked me a question about one of the quantities in one of my equations, and I realized at that time that I had to do some further calculations or derivations on that, but I did not do before the presentation. So I just told the professor honestly that I do need to do some further research on that. And it's actually fine if you feel like you cannot answer one or two of their questions. It will be fine. Just go forward and do not panic. Yeah.
Kind of on the question asking. I know Dr. Laskin said you're going to be interrupted, so don't really practice slide transitions, honestly, because you're not going to be able to do it the way that you want, pretty much. Like, you're going to get derailed, pretty quickly. So, yeah.
That's why practicing with your group is helpful, because they'll interrupt you, so it's actually a real feel of what it will be like during it. I don't think I ever actually practiced my OP once just sitting there staring at my screen, ever, because I just knew it wasn't practical to try to cling on to that. I just tried to be confident in the content on my slides and know what was on my slides.
And to go back to that, some of the questions that were actually asked, I would say that 50% of the questions that were asked during my OP, I had the same questions coming from my practice talk. So I was kind of prepared already, to answer those questions. On my first slide, one question that came up from one of my committee members was well, what if your project doesn't work? What are you going to do? And someone already asked me that question, so I was prepared. And for biochem, at least for me, I had a lot of questions that were experiment-based. So I pretty much had to know all of my controls, why are you testing this, why are you not using the different cell lines and things like that. So for me at least, I had a lot of questions that were experiment based. And okay, you don't have to know the right answers, but if they see that you're at least thinking about it, that's still good.
You should also try to poke holes in your own idea as much as you can.
Yeah.
There were a lot of times when I was going through my idea where I would just think of something and then go into a panic and I'm oh God, I have to throw it all out, but not, look into it and find something that still supports that my thing would still work. And then you want backup slides to answer any question. Every single question I was asked, I had a slide prepared for. There was no question that they asked that I didn't already have the answer ready for. So backup slides for questions. Huh?
How many backup slides did you have?
I think I had 15. Just any little thing you could think of that they could ask you, put a slide at the end of the presentation, just in case.
So you have to make a written report and then slides. So help me understand. You guys, I presume, wrote a rough draft, and then you had your lab mates look over it, and you say, okay, this is a good final draft, and then you started building slides, or was it more of a combination of as I'm writing the written report, I'm building slides to back it up?
So,
how did you handle that workload?
For me, and I think it's pretty common, most don't touch their slides until the written is done, because once you set your date, your written is due 2 weeks prior to that. So then once you already have your written done, it's a lot easier to start making slides. So then you have 2 weeks to make slides, which is realistically enough time. So I did not make any slides until after the written was done. I did try to, through my written, make some of my own figures and diagrams also. So it was illustrated in the report, but also I then had some groundwork for my slides as well.
If there's some changes between your written and your slides, it's also not that big of a deal. I had some, not huge differences between the written and my actual slides that I presented, but there were some subtle differences, and I didn't get a single question on it. So I don't think it's too big if you come up with not some fundamental new part, but if there's some other supporting thing that you want to kind of move to, because once you submit the written, you've submitted the written. That's it. So, but it's not that big of a deal if you just change a little thing here and there.
And I guess kind of piggybacking off of that question, what did you find to be the hardest part of your OP? Was it actually making the presentation based on your paper? Was it writing the paper portion? What, like literally what was like the most frustrating part of it?
The initial idea itself.
For me too, like just coming up with an idea was the hardest part.
Yeah.
After that, it just
Kind of falls into
Yeah.
place.
Yeah.
Determination of the topic, yeah.
Really specifically for me was making sure nobody did it. That was really difficult, and so how I tried to tackle that was if you find a paper that you think is helpful or like related to your idea, there's always ways to see what papers have cited that paper. So that's how I would try to find the newest research on the topic to make sure what like is most current, up to date, to make sure I wasn't copying anyone. That was a huge concern because some PIs, if you think like you're sneaky, some committee members will look up your topic before, and if they find out that it actually has been done before, that means you didn't do your job. So you do need to try to be as current as possible. That was my big concern.
Going on that, how much time do you think your professors put into your RP, whether that is researching the topic ahead of time or actually reading the report? Did they do an extensive job reading the report? What did they?
Might have read it 10 minutes before the OP. Honestly.
That really depends on the
Yeah.
professor. There's professors who honestly probably never looked at the written part. There's professors who read the written part and they will like ask you questions about things that came from a junior presentation. So I would definitely not, like I would definitely write the paper as if like that's your final report. Yeah, so definitely wouldn't use that as like a, oh, I'll just wait till the presentation. Even though the presentation does seem to be what is like you're giving to them and what they're like making their final decision off of, I wouldn't like wait till the last like week to make your slides and like change your topic. So yeah.
Because they can also look at your report as you're presenting. So, because I had some of my community members do that. And one of them actually gave me feedback on my written document after, the presentation and went through the whole thing, okay, what things I can change. So, again, it depends on like the professor. Some will read it totally and some will just do it 10 minutes before. Yeah,
that's something you can, because I think you already take your committee, like the end of your first year, is that I would talk to like other students who like have those professors on your committee and just like ask them like, yo, what type of questions do they ask? Like, do they read it? Do they not? Like, what do they ask you? Because then, like, like every professor has a different style, so the only ones that know are the ones that had them on their like committee. So that's just some advice.
Yeah, like a good example of that, one of mine, as soon as you said your title slide, she immediately asked you what novelty was. And so because I knew of that, my second slide was exactly what I was proposing that was novel. So using, older students as a resource to learn the style. Though also don't completely cling on, because sometimes professors wake up in different moods and do different stuff. It's really unpredictable.
I have a quick question. Dr. Lasker brought up a very clarifying point that you may have to, for conditional passing, I think, you may have to defend a completely different topic. Based on your own experience and your friends, like how often does that happen?
It's a whole spectrum.
Okay.
So it's up to your committee what they decide.
Okay.
There's cases where your committee, I feel like they just want to mess with you and they just want you to do one calculation, and the second you submit it to them, they'll say, okay, you're done. Others will want you to correct more stuff. Others will say, like, you just didn't think your idea through enough, but it's okay in enough idea, but you need to now go more thorough, and you don't necessarily have to rewrite a written one, but you will have to do a brand new oral defense. Others will tell you to scrap your idea, and you do have to come up with a new one. There's a whole spectrum, and it's really up to the discretion of your committee. There's no like kind of clear answers to those.
It sounds really scary, but like I would say like 90% of people pass, or like if not more. Like it's very, like it is rare. Like there are cases, but it's rare. And so like your mentality going in should be like, that you're gonna like make it. Even though like I know that's hard. Like I was in the same boat last year. But yeah, so I don't know, I guess my own advice, like, if I could tell myself, and maybe I'm Stockholm Syndrome now, but like, don't look at it as like a terrifying, like, thing that you have to do, because it is just something we have to do, but like, take the opportunity to like, as like, he was saying, like, you know, like, have fun with it, like, find topics that you don't get to do in your lab, and the more, like Kim was saying, the more passionate you are about your topic, the more like excited you're gonna be, the more likely you're gonna be able to like actually sit down and like look at it and not get bored out of your mind. And so the committee sees all of that. So like if you're excited and you're talking and you can't answer a question or two, like they're gonna be like, yo, you're excited, like that's what, you know, a researcher wants. Like obviously they know you're scared because like who isn't? If you're not scared, then you're probably gonna fail because you're too confident. So it's okay to be scared. You're probably gonna pass. You know, just make sure you are like asking for help. I think in the cases that I know that haven't like passed, it's because they asked for help the day before their paper was due, or they showed you like friends' slides for the first time the night before, and it's like, well, what can I do, right? So just make sure, yeah, you're like telling people what your topic is, telling people like read it. Make sure you're annoying people. Is what really the bottom down is. Like if you're not annoying people, then again you might fail. So
I annoyed my senior lab members constantly, and then other people that had already, you know, gotten their PhD and they're long gone, I've annoyed them as well. So for my friends, I had people like one person just had to rewrite their written, someone had to rethink a synthesis and then represent it, but like those people all passed.
Kim, Dr. Laskin brought up there's a chance you might have to do previous research. You have to like explain, you know, the past 3 years of your research. Did you have to do that in your presentation, or have you heard that's a very frequent thing in the analytical division?
It really depends. I think mine, they ended up asking me to do mine because my oral presentation actually was really smooth and we were done within 30 minutes and I had no questions. So my boss was like, I guess, do you want to talk about your research? I was like, sure. So I did it for 5-10 minutes, but I think like normally my PI doesn't even normally ask that. So you should have it. I mean, that's the bottom line. You should have like 2 or 3 slides, just like generally kind of the projects you're working on and stuff.
I've never even heard of that for like organic division. Like mine went like 45 minutes and I didn't get a single question about actual research, so.
yeah, for the inorganic, like previous lab members had it on there, but in the last like 2 or 3 they have it. And there's only like 4 PIs, so like I doubt it like they like change anything. So I don't think they'll ask me for it, but you know, you don't need to make slides, but just like be able to like tell them. But you guys do that at group meeting and stuff, so like you'll be fine.
I think your PI also actually talks with your committee when they kick you out at the beginning about your research anyway, so.
Yeah, I don't know if you know that, but you go in, basically your committee joins you, then they kick you out, they'll talk about you, and more or less the PI sets the tone. They tell the committee, like, I really do like this person, but it's okay if you annoy them, they can handle it, or like whatever, they'll kind of set the tone. So that's why it's good always to have your PI on your side. Then they'll bring you back in, then you present, then they'll kick you out, decide your fate. Then they'll kick your PI out and your other committee members will just like ask you how grad school is, if your PI is nice to you and stuff. And then you go home and sleep.
But okay, you had a question first.
I was just gonna ask, from the point that you decided on your topic, how long did it take for you to write the written report?
Like finish?
Like, yeah, before like the due date for your written report.
I think I was totally done. I know that I'd wrapped up maybe 3 days before the report was due, and that's when I'd been like, I'm not changing anything anymore.
Was that before you sent it out to people to edit it?
No, that was after sending it for edits and everything. You want to get on that as soon as you can, though. So that probably took me like 2-3 weeks to write it in total.
Just real quick before we continue, it is about to be 3:45. If any of you need to go, feel free. Thank you very much for being here. And if anyone else needs to go, feel free. But we're just gonna chill in here. We have the room till 4. So if you guys have more questions, we're just gonna keep going. But yeah, I don't know if any of you wanted to add to that at all. Sorry for interrupting.
For me, it took me about like a month, and the way it also depends on the way that you write. Like for me, I just wrote it in steps. I wanted to make sure that my aim page was actually decent, and then my idea before I actually start writing the whole 10 pages. So that itself took me like 2 weeks to just go like back and forth with people, because I did send my end page to other people, and then just talking to your other lab members also to make sure that your experiment makes sense. And after that, it took me like a week to write the whole report, and then I sent it to people for feedback, and then another week to just finish up. So a month, I'll say. But I did start reading like in the summer. Like I had like somewhat an idea, like I'll say like end of July, early August, and my OP was like the first week of October. So
I will say a strategy that was like offered to me that I took was I tried to be a good student and start in like winter break before it was like even deep. But like I'm a procrastinator, so that was very different. And then I kept trying to like start it and be proactive, but I couldn't do it. And so finally somebody was like, you're not gonna start it until you set a date. So then I set a date like, 2 months in advance, and so then I was like, okay, I have a date. And so then I gave myself like, okay, by like 2 weeks before it's due, I wanna have it like done and like sent out to people. So if you're like me and you like don't do well without deadlines, like set a date for your OP, and but don't give yourself at least 2 months. Don't be like, okay, I'm gonna do my OP in like 2 weeks. Like do like 2 months, and then that way you have a date, and because otherwise, it's always like, oh, I should start on this. And then also one more thing, I would definitely shoot to start it earlier rather than later. I don't know, you guys did the semester, right? I was gonna say, I would shoot for like August, but it is August. So like, by the latest, like the end of like October, early November. You also gotta be conscious that like, I don't know how many people in your class, but like your PIs start booking up really fast. Like they're doing research, they're teaching, and they're doing other OPs. So like, definitely give them way heads up notice. And you guys were talking about frustrating. I think the most frustrating thing for me, other than the topic itself, was picking up like getting my committee to be able to find like a date where they could all like get together. So make sure you guys are like very open.
How did you organize them? Like, did you do like a when to meet in like the area that you?
Yeah. So
Okay.
based on like my like lab schedule, I just like sent them like a when to meet, and I was like, yo, fill this out, please. And then I just kept reminding them, like, because some of them will forget.
Yeah.
They're busy, so they'll like, you show up at your OP. Like one of my old lab members, like, yeah, like so and so didn't show up to my OP, and that like threw me off the whole time because like then she had to go find her, like like it just changes your like mood. So when to meet, email them like a week out, email them like 2 days before, like again, annoy people.
I had Suzanne on my committee, and she double booked herself for the second hour of my OP, so she's like, let's be done with you first, all right? And I'm like, okay.
Yeah, I was under the impression that the presentation was like 1 to 2 hours, but I'm doing 30 minutes, 45 minutes. Do you guys know what's like typical?
An hour to 2 is the average.
So you schedule 2 hours.
Yeah.
Nobody, like, I think it's rare that they go that long from what I've heard. Like usually, I think at the most like an hour and 30 minutes for most people. So anywhere between an hour and a half. But again, what I was told, at least from the inorganic perspective, was like, if you were to give your presentation, make it at most 20 minutes, uninterrupted, 20 minutes. Because after that, like they start interrupting. And so they also like ask you most of your questions during the bulk of the presentation. So like I had, I don't know, like 20 slides, and I was on slide like 15, and they had only asked me one question, so I started going faster so that I could get done with my slides faster. So once the slides were done, they didn't have any more questions to ask me, and so I had a relatively short, like 30 minutes, which again is like not really common. Like, it's on the shorter end, but you get 2 hours, so in theory it could go 2 hours, but I would say like an hour, hour and a half.
Yeah, and it really just depends. I know people like who had my same committee members who went the full 2 hours, and I mean, I was way under. So it just depends, and I mean, so some things to do to mitigate it, like I said, is not basically overshare information, like not try to do so many calculations that they'll then try to actually test you on it and stuff. You want to try to really actually focus in on what you're trying to communicate and really be direct with that. Kind of on that topic though, you do want to ballpark things. You're not supposed to make up data, but let's say you're building a device to measure something, you do want to kind of have a crude size of like dimensions and stuff like that. If you're trying to measure things or like a concentration of something, you should know what is generally accepted and like to fall within that range, because they will ask stuff like that so they can kind of assess, does it even make sense? Like, would this be possible? So I think the word I use is ballpark. You want to have a general idea like of some kind of numbers.
Yeah, I had a question about that, especially about the data you use for literature examples you would use to support your idea. Like, this is, in the case especially where your product is related to what you do, like how much of a balance is there between, like, saying, between using precedent of papers that you published of examples you can relate possibly in terms of like the values and the way the data looks, versus like you're saying that you expect this because this is how this other system works, and this is just how theoretically it should work, and or just saying like, you know, I'll use this equipment to measure that, and I expect this, and just leaving it there. Like, how do you balance being kind of more specific on the data for this kind of novelty, but also not being too vague, where it's like, you know, I'm not really certain, but I know how I can measure it, and then you're making it seem like you don't really know what you're doing. If that makes sense.
What I would say is you want to try to get data like closest to your like what you're actually trying to like figure out. If you can't find an exact value, find something closely related and then say how you would find that value. That's kind of what I did for like some reduction potentials that I just could not find.
So you kind of balance, like, you know, you say you're going to do these types of experiments, you try to find examples you can pull from support that your idea will work based on some other system, and kind of interpolate that throughout the paper.
Yeah, so like for example, one part I had was like gold nanoparticles, and so I learned what like normal diameters are for a specific thing I did. So I had to those still synthesize and modify them. So I was saying how I would do it, and then what I would do to measure like the actual size, and then like if it's too big or too small, then what would I do, kind of thing. But I didn't necessarily come up with my own data. I just tried to think of what am I making, how would I characterize it, what does that information give me, and then how could I fix it if necessary, if that makes sense.
Yeah,
and I know a lot of professors also say to not make up your data.
Yeah.
But that also depends on like the question you're trying to answer. Like for me, for example, again, I'm part of the Biochem division. So I had like one of my sub-aims was just like a dose response curve, for example. But like the concentration of the drugs I was using, I had a starting point and like an ending point, like the minimum I can use and the maximum I can use. And you can find those values from the literature. And I just like mimic like a graph of what I think it's gonna look like with my system, but I didn't have like numbers. And I did have one of my committee members asking me that question, or like, how did you come up with these concentrations? And I was just saying that, oh, like in the literature, this is what they did, and that's why I think this might work. So.
And that's generally accepted, like
Yeah.
having a graph but no figures, more so just to show kind of like what the shape of like the data or line would look like and why would it look like that, but do not assign a single value to it. That's kind of how you walk that line.
all right, thanks.
Any more questions before we close out? All right, well, thank you all for coming. Let's thank our graduate student panel again. Thank you guys very much. But yeah, expect this to be online within the next week, just in case you need to refer to it. But other than that, good luck.